Finally, what we've been talking about for a little while, we're actually going to finally do it, is using the quadratic equation. And the quadratic equation, let's write it out over here on the side, is a very long thing. You do not need to memorize this. We will give you this, write it up on the board or give it to you on a sheet of paper on your test when you take any quizzes or tests. But the way it goes is we're trying to find our x-intercepts. So we're always going to say x is equal to, so this is going to help us find our x-intercepts, and it's going to be a big fraction. And on top we're going to have negative b, and then we're going to write plus or minus. So we're going to use the symbol plus or minus to say that there's actually two things. We don't want to write this thing out completely twice, so we're just going to combine it in one symbol. The square root of b squared minus 4ac, you might recognize that from earlier, and all of this is over 2 times a. So all of this over 2a. This part in the root, the b squared minus 4ac, that's our discriminant. That's what we had from earlier. The reason that we looked to decide if it was positive, 0, or negative is because eventually we're going to take a square root of it. If we take the square root of a positive number, we get 2 real solutions. If we take the square root of 0, we get 1 real solution. And if we take the square root of a negative number, there is no real solution, but we can get imaginary ones. We can take the square root of negative numbers if we use I, like we did above here. So this formula is what we're going to use to calculate the actual answer to the x-intercepts. So I'm going to start out with one that's a little bit more straightforward. We're going to do this problem right here. If we figure out our a, our b, and our c, a is going to be a positive 4, b, the one in front of the x, in this case the m, is a negative 1. The 1 isn't always written there. And then our c is going to be 5. So we're going to take these numbers and plug them into this big equation. So x is equal to negative 1, so double negative, negative 1, plus or minus the square root of b squared, so the square root of negative 1 in parentheses squared, minus 4 times 4 times 5, 4 times a times c, all of this over 2a, or over 2 times 4. Now, if we're going to clean this up, the first thing I'm going to do is look at the beginning here where I have negative 1, and I know that that's just a positive one. Negative is a positive. Plus or minus some square root. If we look inside the square root, we have negative 1 squared, which is 1, minus 4 times 4 times 5. 4 times 5 is 20. 20 times 4 again is going to be 80. So we really have 1 minus 80, or negative 79 in the square root. And then on the bottom we have 2 times 4, which is 8. I always recommend doing it this way, where we simplify the far left term, we simplify the part under the root, and then we simplify the bottom. Don't try to do this any faster or skip any more steps than that. There just always seems to be issues when you do that. Our next step now is to convert this into something that doesn't use square root of a negative number. So if we had a positive there, we could just take the square root. Here we need to use I. So we're going to say 1 plus or minus the square root of 79, I, and I'm actually going to type that into my calculator. I want to figure out what is the square root of 79. And my calculator says 8.89 if I round it off. So 1 plus or minus 8.89 I over 8. Whenever you end up with something with an imaginary solution, you can actually leave it just like this, and this will be an acceptable answer. If you didn't have any imaginaries, you could completely solve this and get it down into 2 numbers. And so we'll take a look at an example that does that over here. So in this one here, you'll notice that we're missing a p term. We have a p squared and we just have a number. So we have a equals 2. We don't have that p term, so b is equal to 0. And then our c term out here with no p, negative 72. So we have a, we have b, we have c. And if we're going to plug this into the quadratic equation, we always start out with a negative b, so negative 0, plus or minus the square root of 0 squared minus 4 times a, which is 2, times c, which is negative 72. Let's keep that all under my square root. All of that is written over 2 times a, or 2 times 2. And just for keeping track of what we're actually doing here, it's always good to put that x squared out, or x equals out front. Cleaning this up, I know a negative 0 is just the same as saying 0. And then plus or minus my square root of, I have inside 0 squared, which is 0, minus 4 times a times c. So negative 4 times 2 times negative 72. I'm going to do that one in my calculator. Negative 4 times 2 times negative 72, and I get 576. And that's actually going to be plus because I had a negative here and the negative here, so it's going to be positive. So 576, all of that over 2 times 2, which is 4. Take that one step farther. The square root of 576, if I were to type that in my calculator, is going to be 24. So I get 0 plus or minus 24 over 4. This is the part where I'd recommend breaking it up into 2 separate problems. So on one side I have 0 plus 24 over 4, and on the other part I have 0 minus 24 over 4. The plus or minus is really saying one problem should be plus and a new problem should be minus. So let's solve each of these separately. 0 plus 24 is just 24, and 24 divided by 4 is 6. 0 minus 24 is negative 24. Divide those and I get negative 6. So in this case, my two answers end up looking very similar. One's positive and one's negative. It does not always work out that way. But these are my x-intercepts, or my solutions, or my roots, or my zeros. Remember, there's lots of different names we have for those two terms. But that would be how you find it on both of these problems. In this case, we have 2 reals. In this case, we have 2 imaginaries. So good luck with the remaining problems.